Okay, so chloroplast and the light reaction. A chloroplast is an organelle, and as an organelle, it has It has a membrane. It is a membrane-bound sac, but inside of it, it has more membrane-bound sacs. They look like stacks of pancakes. The entire stack of pancakes is referred to as a grana. The grana are made up of individual thylakoids. So the grana are made up of individual thylakoids, and the thylakoids are what we're drawing down here. So this whole process essentially takes place on one little section of this membrane. So what that means is this area in here is the thylakoid space. And it is where all the hydrogen builds up. The actual line is the thylakoid membrane. This is our thylakoid membrane. Now there are a whole bunch of these in here. There would be tons of these grana stacked inside of here, all with individual thylakoids. And all around them is a liquid. And that liquid out around them is going to be what's called the stroma. Now, what this gives us is now we got to look at this and go, the stroma is out here. That's where the Calvin cycle is. So stroma, this is where the Calvin cycle or dark reaction occurs. So the Calvin cycle, and remember there'd be a lot more of these, but that'd mess up how much space I've got to write. Thylakoid membrane is the light reaction. And then the thylakoid space, that thylakoid space is going to be where we have our H plus buildup. This is where the H plus gradient will build. So the thylakoid space has an H plus gradient. The thylakoid membrane is where we have the light reaction, and then the stroma is where we have the Calvin cycle. Now another thing that helps a lot of people, since we've already done respiration, is if you compare this to like a mitochondria has all this extra internal membrane, and a mitochondria uses that extra membrane very similarly to the way that a chloroplast does. So that what happens is you have your inner membrane. So on the mitochondrion, you have your inner membrane. And that is where you're going to have your electron transport chain. You have your matrix. The matrix is very similar to the stroma. And then you have your intermembrane space. So you have your intermembrane space. So on this one, the inner membrane is where you have the electron transport chain, which is most similar to our light reaction over here. And then you also have your matrix, which has Krebs going on in it. So you have Krebs in the matrix. Krebs is essentially the reverse of the Calvin cycle. And then you have your intermembrane space, and that's where your hydrogen builds up. So where hydrogen builds up inside the thylakoid, that's what the intermembrane space allows to happen in the mitochondrion. So this will allow you to draw some similarities and some differences between chlorophyll, or chloroplast rather, and mitochondrion. Now the other thing that's helpful to remember is that if we're looking at the net reaction for photosynthesis, the net reaction is CO2 plus H2O goes to C6H12O6 plus O2. Now, this O2 is produced right here on this membrane. The sugar is produced in the stroma by the Calvin cycle. the H2O got used up right here in the light reaction, and the CO2 got used up on the Calvin cycle in the light reaction. But this is the net reaction for photosynthesis. Now, to turn this into respiration or combustion, all you got to do is turn that arrow around. If you go from this side back, that means that what happens is you take C6H12O6 plus O2 and you make H2O and CO2. So in essence, the calories you actually eat and use, you breathe in oxygen to break them down, and then you urinate them or exhale them away and you breathe them away. Anything you actually used comes out as a liquid or a gas. And this would be the reaction for respiration or combustion. It's the same reaction. Okay? So that should give you your net reactions. Hopefully that's enough to get you guys on the right track and set up for your test. I'll see you later. Have a good night.